Uh, Hello and good afternoon, everyone. Thank you for joining this lunchtime seminar on recovery operations in the Philippines and earthquake hazards in India. My name is Mohamed Elzeadani, and I chair the Young Members Subcommittee of the Society for Earthquake and Civil Engineering Dynamics. I'm delighted to have with us today Andrea Manenti and Alice Turner, who will be speaking to us shortly. This event is organized by SECID, EFIT, and the ISTRUCT Midland Counties Group. So thanks both to Sarah and Alfred for all their efforts in putting this event together. Just a few information before we begin. Please keep your video cameras off and microphones on mute for the duration of the presentation. Please also note that there will be a Q&A session at the end of the presentations, but if you have any questions during the presentations, then feel free to drop them in the chat. Also, please note that this seminar is being recorded and will be uploaded to our SECID YouTube channel. Therefore, by joining the call, you consent that any views or information you share will be made public. Also, just a quick announcement before we begin. So applications for the SECID Fund 2026 are now open with the deadline on the 31st of July. So this is an award of up to £1,500 and it's designed to support individuals or teams who are seeking to further their studies, research or career in the field of earthquakes and engineering dynamics. And to apply, you just need a valid SECID membership. So I'll post the link to this opportunity in the chat shortly after. So please do consider this opportunity and also apply for it if you work in a relevant field to earthquakes and engineering dynamics. So that's for me. I pass over to my co-chair, Sarah, to introduce our speakers for today. And thank you very much.
Thank you. I'll just introduce our first speaker, Andrea Manenti. He's a director of Booth King Partnership, a civil and structural engineering firm based in Manchester. Andrea has dedicated the last 18 years of his free time to the international development sector, serving as an active delegate for the British Red Cross as a sanitation engineer and for the Canadian Red Cross as a shelter delegate. Andrea has undertaken extensive Red Cross training in his own time to strengthen his ability to support technical teams and be deployed when his specialist expertise is required in response to natural disasters or conflict situations. Our second speaker is Dr. Alice Turner, who is an earthquake seismologist. Her research focuses on understanding what causes earthquakes on the Earth and the Moon by analyzing data from the seismic waves that are created during an earthquake. During her PhD at the University of Oxford, Alice studied repeating earthquakes on the Earth and the Moon. She then took up a research fellowship at the University of Texas Institute for Geophysics, where she continued to work on earthquakes on other planets. Alice joined the Department of Earth Sciences at the University of Cambridge as a research associate in January 2025, where she'll be working on a project to understand earthquakes and seismicity in India better. So thank you. I'll pass on now to our first speaker, Andrea Manenti, to get us started.
Well, thank you very much, Sarah, for the introduction, and I'll start immediately sharing my presentation. I'll try being as quick as I can. I've got about 20 slides, and I will make time for Alice because she's got a very exciting presentation. So this is about my recent experience in the Philippines to support the Philippine Red Cross as a search delegate for the.
You're muted, Andrea, by mistake.
Okay, can you hear me? Apologies. Sarah introduced already myself. I put my experience into context. At the moment, my work day-to-day work is a structural engineer, and I'm based in Manchester. But if we go back a couple of decades after my degree in Italy, I've moved to the UK and worked for Bureau Happold. Bureau Happold in 2008 gave me the opportunity to spend a year in Africa with an Irish NGO called Gold Kenya to develop some school projects, latrines projects, and water projects. has the projects progressed? There was an outbreak of cholera in Zimbabwe, and I've been asked to become a sanitation engineer and tackle the emergency as a sanitation engineer. And from there, my experience then started also with the Red Cross, because as I came back from that experience, I joined the British Red Cross as a sanitation engineer. Following that experience, I had also the opportunity to work in East Africa as a consultant for an engineering and architectural firm called FPW, and that gave me the opportunity to work for 4 or 5 years in East Africa. And when I returned to the UK, I joined Booth King. Since then, that was about 2015. But about in 2018, I joined the Canadian Red Cross as a shelter delegate, and I've developed a series of trainings that allow me ultimately to be deployed, this time to the Philippines. But in the past, I was deployed in Ukraine for a winterization program, and also in Bangladesh in 2018 for the Rohingya.
Oh, you're muted again, Andrea. Okay.
Okay, let's jump straight into my experience. Early in January, I was deployed to the Philippines to support the Philippine Red Cross, because in recent time, between September and November, as you can see, a series of typhoon and a series of earthquake heavily affected the Philippines. In particular, pay attention to that red dot in the middle of the screen, because that is Bogo City, and that was the epicenter of an earthquake that struck in September the 30th with a magnitude of 6.5. Pay also some attention of Tino typhoon that strike from east to west, and it's the brown line just at the bottom of that Bogo City epicenter. My role, what I was deployed with and for, I was deployed as the shelter program coordinator for the IFRC search team, so the International Federation of the Red Cross, as a second rotation as an engineer in support of the Philippine Red Cross, and in order to develop a early stages of mid and long-term recovery strategy for the shelter cluster, call it. So I spent about a month in the Philippines, traveling from Manila to Bogo City and Cebu Island. So you can see that there is in the middle of the image, there is a yellow dot. That is where the earthquake struck in Bogo City. But you can see that Cebu Island was also affected by Typhoon Tino. A little bit of understanding of what the mechanisms of deployment for the Federation are. Many of you may not be familiar with the mechanisms of deployment and how the international development would tackle the responses, the emergency responses. So the two major agencies that are leading in terms of response for the disaster is the International Federation of the Red Cross and Red Crescent, together with the United Nations. The IFRC is then made out of 191 national society, as well the ICRC, which is the International Committee of the Red Cross, that often is involved in conflict area. So how we work in my scenario was called and deployed early in January, but the deployment call came from what is called the IFRC Rapid Response Deployment. And that is issued by the Federation, and myself being part of the Canadian Red Cross as a shelter delegate, I was briefed pre-deployment by the Canadian Red Cross, as then I joined the deployment under the IFRC surge team to then be post-deployment and end-of-mission debrief by the Canadian Red Cross itself. The mechanisms are fairly sophisticated, but this is how, at the moment, at the present, is working. The response generally to a natural disaster as a time frame is set as an early emergency response that usually is between 0 and 3 months. There's an early phase of recovery and then a long-term recovery that goes from 3 to 9 months and from 9 to 24 months. So what we're seeing here is already a time frame of the specific case of the response to the Philippines, as well as the response that the shelter department of the Philippine Red Cross decide to tackle. So where you see today is where I received the call. So the earthquake, if you notice on the previous slide, the earthquake in Bogo City happened on the 30th of September. So the early stages of response happened for the first 3 months, and I will take you through what the response was. You can see behind there emergency shelter assistance, shelter upgrading support, shelter repair assistance, and full shelter assistance. So the Philippine Red Cross started already developing a response when a few weeks later the Typhoon Tino happened. So Cebu Island was particularly affected because at the same time after the earthquake, they were affected by the typhoon. So the Philippine Red Cross has to reassess the response they wanted to provide, and based on the disaster that were happening simultaneously. And then a few days after Tino, that happened the 4th of November, on the 8th of November, the Typhoon Uwang that happened to the northern part of the Philippines strike as well. And that was also part of the response of the Philippine Red Cross. So to put that into context, the Philippines is made out of more than 7,000 islands. So the logistic of reaching the affected area are incredibly difficult. But to give some number that combines the impact of the Typhoon Nando, Tino, and Uwang, together with the Cebu and Davao earthquake, is within that slide, and it's just to put into context. So about 196 provinces were affected. These are divided by municipalities, barangays, which are the small villages. More than 20 million people were affected by this natural disaster. Luckily, the death roll was relatively slow, as you can see, and about 1 million people were displaced, and that's what is called IDP, internally displaced people, and approximately 1 million houses were damaged. Now, that damage was quantified in 2 separate different type of damage. One is totally damaged and partially damaged. And that was a criteria that was applied both to the typhoon response and the earthquake response. Now, by the time I became operating in Erling, or I arrived in Manila, that was the brief that I received by the Philippine Red Cross. So the funding was already in place, and the funding came from the Federation, the American Red Cross, and the Korean Embassy. And the objective was to provide and restore and improve the livelihood and shelter, to improve living condition and reduce disasters risk, supporting long-term approach of building back better and safe. And I think we need to bear in mind what this build back better and safe mean, because I will take you through in the next few slides. What we've defined, and I will shortly explain what shelter repair assistance or transitional shelter or these elements are, but to put into context the quantity of the response of the Philippine Red Cross based on the funding is there within the quantity. So shelter repair assistance is within 1,000 numbers between the typhoon response and the earthquake response. Transitional shelter was 300. So we've seen in slides before that the affected number of totally damaged houses was about 100,000. and the support that the Philippine Red Cross could provide based on the funding is 300. So that needs to have a bit of a scale to understand the impact that can be made, which was relatively limited. Livelihood and shelter usually work hand by hand, because inevitably shelter may mean displacement, and displacement means not only moving away and apart from your original house, but means also linked to livelihood, what you're surviving with, what your work is, and so on. So going into the detail, if the emergency shelter assistance, this was one of the things that the Philippine Red Cross decided to assist the local population with as soon as the earthquake or Typhoon Tinan happens. So what can be provided to the populations that has been just affected by the disaster? And the first things that they need is probably tabs and some shelter toolkit. I remind you all again that this is just from a shelter point of view. There are other responses that usually are in place by the Federation, which includes health and care, water and sanitations, cash and financial assistance, which is very important recently, food security and livelihood, and so on. But from a shelter point of view, is what people may need to make a first repair to their houses is what you see here. And to do the distribution, this next image that I actually taken was when a distribution in a local barangay was happening. Now, if you do remember, the emergency lasts about 3 months, and then you naturally goes into what is called an early recovery. So this was a distribution that happened fairly late, because the mechanisms to assess how the distribution could be made to the main households that were affected, it was a very difficult thing to do due to the fragmented situation of the Philippines itself and the logistic of reaching out all the affected people. If you can see that image, and one of the important things, there's on the bottom left, there's 2 volunteers for the Philippine Red Cross. They are holding a sheet with some information on how to build better and safe. So any of these families would have gone back home to their shelter that were damaged and try repairing, and that message is an educational message in try rebuilding better and safe. And I will take you through some slides later on. Past the emergency, then there's 2 other supports that the Philippine Red Cross has created. One is a temporary shelter, or what was in the previous slide called a shelter upgrading support. So we are already entering an early recovering phase. People start to think already after the emergency to go back to their own houses, or eventually remain in what could be informal settlements or evacuation center in case they cannot return to their houses. So it's a shelter support assistant in this case was there with the provision of 2 or 3 pieces of tarpaulins, and then a shelter kit and cash for material that nowadays is a very useful support that can be provided, labor support and capacity building, which is building back safe and with building back safe principle. So we are in a temporary scenario. In this situation, people can either rebuild the temporary shelter, which is better and strong than the temporary shelter that they be able to provide at early stages. And this temporary shelter could potentially become the permanent shelter. there are a lot of mechanisms here that affect the shelter and settlement assistance, which is to do with something I won't have the time to speak about, but is important. It's called house and land property support. So if there is a relocation of a family somewhere else, what are those mechanisms that allowed the shelter to be in and the household to settle in an area that is safe from a security of tenure as is defined. And then we're moving here into the situation where the household of the family, they haven't moved or they've been relocated, but they are staying within the original shelter. And the shelter repair assistance that was provided to simply allow the families and the households to strengthening the existing or repair the existing shelters. And ultimately, going into a more permanent solution, and what the Philippine Red Cross developed is also what was called and defined a transitional shelter. So we are going to a long-term solution, and this is to rebuild the shelter. You can see the amount of money, 133,000 Philippine pesos is approximately £1,500. And with that amount of money, they could rebuild a shelter in a new relocation area. The Philippine Red Cross supporting on the design, on providing the material, or providing cash for material, labor support, capacity build, and also what I mentioned before, which is house and land and property support. And this is what I found when I arrived. So the disaster or the first earthquake happened 3.5 months before. People have naturally relocated in an informal settlement. They used the government blue sheet to create their own shelter. As you can see, these have got very limited lifespan, 3 to 4 weeks. And then they need some replacement. And as I mentioned before, the scenarios they have seen and witnessed between earthquake impacts and typhoon impact and the response was slightly different. And these slides, which I rushed through simply because I'm conscious of time, is just to make everyone aware of that difference, that the response and the impact needs to be tailored to what the disaster effectively is. We spoke before about Build Back Safer key messages. There were 8 slides and flyers that were distributed to the population to just educate them in how they could rebuild in a safer way. And that was what the volunteers of the Philippine Red Cross were presenting in the images I showed before. Build on strong foundations, tie down from bottom up. So all the tight process, even during the upcoming strong wind, bottom right of the slide. Brace against the storm. So all the structural engineering in these teams they well know about vertical bracing. Use strong joints. A good house needs a good roof. Many of the shelters that I've seen in typhoon affected area, they lost the metal deck and the metal roof. So a good house needs a good roof, and site your house safely. So if you need to relocate somewhere else, then find the right site rather than being close to the coast or too higher up in the hills. And these were messages that were distributed throughout the emergency phase. Also very quick slides, simply to point out that IM, which is what is defined information management now, is becoming more and more a relevant element. These are things that are an information that captured by delegates deployed by the federations or experts that simply helped collecting the data. And that collection of data and the dynamic of change of that data on a daily basis was large. Was very large. So thanks to IM, there's a level of coordination. If you see at the top right, this is a slide that was taken from the Philippine Shelter Cluster, which is simply an entity that by coordinating not only the response from the Philippine Red Cross, but also by all the other agencies that are responding to a natural disaster. And I think it's probably worth showing you some images they have taken in the affected area. First, on the typhoon side, and you can see houses close to the river. So flash flooding, and the houses were washed away or damaged. This was a bridge, and you can almost see at the end where the road was, and that was again a road fully washed away by the power of flash flooding. And this is a closer picture to that. Houses completely washed away. You can see the foundation of a house that was washed away by the river, and here the same. That's so much to say in that image. Originally there was a bridge where you can see that concrete structures, and that is an early response and recovery of the local population. That bridge was cutting off two areas of the same village, and people simply, to access one side to the other, they rebuilt their own bridge. Same scenario, houses washed away from the river, and the same here. There were 300 houses in that corner. They were all washed away as I was there. And similar scenario, this is show the level of the river, and the level of the river is linked to this bridge. So the bridge created almost an obstacle to the intensity of the flash flooding, and that water then flooded the entire village up to the second story. An entire village in that scenario had to be relocated. This was in Negro Island, and that's one image of again of the same area. The earthquake at Bogo City is a different scenario. So I found as a disaster. So houses completely collapsed, and no vertical bracing used. And this is a rural area affected by the damages. So poor material use in first place. Concrete foundations, we're seeing in some previous slides, they are damaged and erased shelter, and building with no vertical bracing for the structural engineers in this call. And this is also something interesting. This is a sinkhole. So a series of sinkholes were naturally created after the earthquake. And that's also sinkhole in a village, just in a central part of a village. And that's again the level of destruction of the earthquake. That was a landslide due to earthquake, and some more images that shows the extent of it. And as I'm reaching the end of my presentation, apologies to have rushed into it. I link to what Alice is going to present, because the second to the last image is not clear, but show pictures I've taken about a fault line that was created along the coast, and the last image that was taken by a website called geoengineer.org was an article published about the depressions and the of a line cost of more than 1.5 to 2 kilometers, and that dropped the land dropped about a meter. You can see the consequences of that. The article pick up the request from what is called the Civil Port Authority to the MGB, which is the Mines and Geosciences Bureau, to basically do a research to assess the hazard and risk of that depression within a port area in some local area within Cebu Island. I'll point you out just to close about the what I've witnessed in particular at the earthquakes in Bogo City is really poor construction material. One of the elements for all the reinforced concrete structures is that the sand that was used was sea sand, and we well all know that that retains a high level of chloride content. The chloride content affects the reinforcements within the reinforced concrete that will allow a progressive deterioration of and corrosion of the reinforcement. And then is lack of earthquake resistance construction methodology. So that build strong back and strong is really something that is key and essential to limit the damage to typhoon, but also earthquake. I point you out ultimately to two websites that you may want to see, which is one is the website for the Mines and Geoscience Bureau, and the other one to the Institute of Volcanology and Seismology of the Philippines. And I pass straight the talk now to Alice, and sorry for the rush. I tried compressing everything within my time space. And Alice, this is to you now.
You're muted, Alice.
Okay, I'm unmuted.
Yes.
Can everybody
Brilliant.
see the slides? Okay.
Yes, we can see the slide.
Perfect. Thank you, Andrea, for such an interesting talk. And yeah, what I'm going to talk about kind of really links to that end bit of those photographs that you were showing of the fault zones that you saw. So I'm an earth scientist, a geologist, and in this talk, I just want to talk a bit about trying to understand earthquakes in India, where they happen, how big they are, and hopefully how this can kind of how this tectonic picture can feed into what you guys on this call think about. So firstly, motivating that earthquakes are a common occurrence in India. And so I've just put up two fairly recent examples of large and damaging earthquakes in India. So the first one here is this 2015 earthquake that actually happened in Nepal, but tectonically. So this earthquake, as probably many people on this call remembers, was very devastating. So over 9,000 deaths and 3.5 billion in damages to houses. And so this is occurring along the Himalayan mountain belt, which is where the most of the seismicity in India is happening. And I'll go back a little bit into the geology of why that is and the tectonics of why that is in the next slide. But I think the important thing that I want to kind of make clear in this talk is actually earthquakes can also happen far away from this Himalayan plate boundary. So this is an example of the 2001 Bhuj earthquake, which happened kind of a large distance away from the Himalayas, where the population are less prepared for earthquakes. And this caused 20,000 deaths and nearly 400,000 buildings were destroyed. So had a really big impact, despite the fact that this earthquake was actually a smaller magnitude than this, the 2015 Nepal earthquake. So the aim as an earth scientist is to try and better understand where and how big earthquakes could be using the rocks and observations that we can make and the physics of earthquakes to try and understand these problems. And so first of all, I'm going to kind of go into the big picture reasons of why earthquakes happen in India and the tectonics. And that reason is basically, you can think of the peninsula of India as a big chunk of rock, and it's crashing into Eurasia. So that's what you can see in this figure on the left-hand side. So India is progressively moving into Eurasia, and as that happens, it's squishing up the rock in Eurasia to create the Himalayan mountain belt. And also you can see that there are some faults, kind of strike-slip faults on the edges. So some of that material is being extruded out sideways. So we have kind of uplift from mountains to accommodate that deformation, and also sideways extrusion. And so I'm going to quickly cover kind of what common observations we can make to know this is what is happening. And so the first one of these is GPS or GNSS. And so this is where you place out a GPS sensor, and this can tell you the relative motion of the place where that sensor is placed. And you could see here that each of these blue arrows is the measurement from a GPS sensor relative to India. So you can see that at this location, it's moving northwards, so accommodating that deformation as India crashes into Eurasia. And in this GPS picture, we can also really see the kind of sideways extrusion as well. So along strike-slip faults moving sideways, you're getting motion out this way and down as well. So actually earthquakes that maybe you wouldn't associate with directly with the Himalayan collision, for example, earthquakes in Myanmar and things like that, are still related to this big picture tectonics of India crashing into Eurasia. So the second way that we can try and understand and quantify this deformation is using earthquakes, which is what I mostly focus on as an earthquake seismologist. So this is a slightly complicated picture, and each of these little beach ball looking symbols actually represents one earthquake. There's slightly more into that I don't have a lot of time to go into, but we can see that there's lots of earthquakes happening in here. And so as the faults slip, they're again taking up that and accounting for the deformation of India crashing into Eurasia. And then finally, you can go out into the field and find those faults. So the two methods that I've kind of briefly covered in the previous two slides of GPS or GNSS and earthquakes are both remote methods. So I can have a look at those sitting at my computer here in Cambridge. But another way to do it is to just go out into the field and find these faults and map them out. And once we have a better idea of where these faults are, we have a better understanding of how this deformation is being accommodated through these different faults and where earthquakes could occur, because earthquakes generally occur on pre-existing faults. And so in this talk, that's kind of the first part of what I'm going to talk about is some field work that we did looking into finding faults. So where do these earthquakes occur? And then in the second part, I'm going to talk about some more work that we did thinking about how big these earthquakes could be once we know what faults are happening. So starting off with that first part, where do the earthquakes occur? And so the way that we do this, sorry, this picture is slightly pixelated, is that when an earthquake occurs, it leaves a trace on the landscape. So similar to those pictures that Andrea was showing of the faults and the subsistence of the earthquake has changed the land and it's now flooded. That's showing you that one side of the land has moved down. And in the case in India, we're specifically looking at a compressional setting along the Himalayas where India is crashing into Eurasia. And so that means that as you're squishing the material, one side of the fault is going to move upwards relative to the other side. And so we can look for the evidence of the uplift, so a step in the landscape, and then to really confirm that this is from an earthquake and not from some other process, you can look to see where the layers of rock should have matched up with each other. And so when this was flat, these two brown layers would have been next to each other. And as one side of the fault has been pushed upwards, you can see that the layers have been displaced. So that's what we're looking for when we go out into the field to look for these earthquake faults. We're looking for linear steps in the landscape and this offset. And so we carried out two fieldwork campaigns in 2025 and 2026. So this year, And we were up in Himachal Pradesh, which is kind of up here along the front of the Himalayan mountain chain. And the aim of this work is to map out the faults that are kind of along this, the Himalayas that haven't been previously put onto maps. And so from now on, I'm just going to show you some pictures, and hopefully you can get your eye in to see where these faults are and how we see them in the landscape. So this is the first picture of a fault, and I've just drawn a line here to illustrate. So we have a flat surface here, and then a slope down and another flat surface. And so we can see where in the past, the earthquake has lifted one side of the land upwards relative to the other side. And so it's just flipped relative to that little cartoon that I showed you earlier. It's the other way around. And so here we are, we have another example of where, again, we can see there's a flat layer up here, and then a step, and then a lower layer. So again, we have one side of our fault being lifted up relative to the other side. And this time we can go over here and confirm the layering. And so you can see that we're basically in an environment that is made of a bunch of rocks from river gravels. And you can see this is the riverbed here. And so when we're standing down on this lower level, we're just standing on that river gravelly material. But when we come over to the side that has been uplifted, you can see that this is a little hat of gravel on the top. So this layer of rock that you can see that it's made up of lots of different pebbles, that is the river gravel that was on the lower layer down here. So we can confirm that this step in the landscape is because one side, this side here, has been lifted upwards relative to the other side. And I just want to note these buildings here. Actually, there was a lot of construction going on in this area. So this is actually a building that's being built, sitting right on the fault zone of this fault. This is kind of a common thing that we saw when looking through the landscape, that there are many, many faults preserved in the landscape and also many buildings right on these fault zones. And so I have just one last example of this. And actually this was on the first day of the first week of fieldwork that we did. And our hotel was actually about 100 meters down the road from this location that we looked at. And again, you can see the mountains that you see in the front. So that's the front of the Himalayas. So we're kind of looking along the range, the front of the Himalayas, and we can see this fault here. So we have a lower level down here, the steppe, and this higher level where there seems to be kind of this football field or this school. And when we go and look at the rocks that are made up of this, we can see again that the river gravels have been uplifted. And again, we can see this was a little hotel that is right on the fault zone. And so this is just some examples of where we've been looking around to try and better map out where these faults are, because these ones were not on any geological maps or in any of the kind of hazard assessments for the region, but these kind of recent earthquakes, recent faults that were created by earthquakes could possibly be the thing that hosts an earthquake in the future. So that kind of covered where the earthquakes could occur. But the next question we want to answer is how big they could be. And in this, I'm going to talk a little bit about the Himalayas again, but then move on to this situation of earthquakes that are occurring far away from the plate boundary. So in seismology, the way that we define the size of an earthquake is through the moment magnitude, which is basically a measure of the energy that can be released. And this can be translated into the magnitudes that are normally presented in the news. But this is kind of a scientific way of describing this, and it's proportional to the shear modulus or the strength of the rock, the area of the fault, and the slip that occurs across that area. And so basically, we can say that the magnitude of an earthquake is proportional to the area of the fault. And so that's just what I've illustrated here with this little cartoon. So a magnitude 6 earthquake has a smaller fault plane relative to a magnitude 8 earthquake, which has a much, much bigger plane. And so if we want to kind of estimate the maximum magnitude, we want to get an idea of how big the biggest fault could be. And so this is where generally, earthquakes are pretty similar length scales, down dip, so into the ground, as they are along the top of the ground. And so we want to understand what controls this top length, and also what controls this length down into the ground of the fault. And so just wrapping up with the Himalayas is that it's really important to know that faults can be segmented. And so along the Himalayas, so this is the Himalayan mountain belt, there is a fault, this red line, that runs all the way along, but it doesn't rupture the whole thing in one go. What we can see here from these historic earthquakes, which are outlined in yellow, is that small segments of the fault rupture each individual time. So for example, this is the 2015 Gorkha earthquake, which I used in the illustration right at the beginning. And so that just ruptured this small segment. And what controls this kind of segmentation of the fault is kind of an ongoing research question. But quite often it's related to the geometry of the fault, so where it bends. And so then you can get an idea of this bit of the fault until this bend will rupture, and probably it will stop there. And so that gives you that kind of along the surface length scale to help you constrain the magnitude of the earthquake. And so that's in the Himalayas. And then I also just want to touch on these intraplate earthquakes, so earthquakes that are happening in the Indian Peninsula far away from the Himalayas. And so in this case, the faults aren't normally these long, continuous things that we can look at fault segmentation. And so to think about the maximum magnitude of the earthquake, we're going to think about that other length scale. So how deep down into the ground can it go? And so this is kind of, again, thinking about the size of the fault plane, and we're now looking at the depth that it can go to. And we say that the deepest depth that a big fault plane could be is the deepest depth of seismicity. And so here in this little cartoon here, you can see that if the earthquakes, the smaller magnitude earthquakes that you can observe, don't go very deep, that means that you wouldn't be able to have a large magnitude earthquake. It's just limited by size. Whereas if you have seismicity going really deep all the way through the crust, that means that the maximum size of an earthquake could be very big, because the length scale could be all the way through the crust. So it's basically areas with deep earthquakes or deeper earthquakes could have a larger magnitude earthquake in the future, just based on this idea of a bigger fault plane means a bigger earthquake. And so what we want to do is look for the maximum depth of seismicity across the region to help us map out where could be the largest magnitude earthquakes and where is likely to have smaller magnitude earthquakes. And so this is where I'm just going to quickly touch on some seismology, but if you don't follow this, that's absolutely fine. But this is how you calculate an earthquake's depth. So when an earthquake happens, it sends out seismic waves that travel, they're elastic waves that travel through the earth, and they can be measured at some distance by a seismometer. And there's kind of different types of seismic waves, and they can take different paths. And so in this illustration, the different colors are different paths that the seismic waves have taken. And so this dark blue is the direct P wave. So it goes directly from the earthquake to the station, which is represented in this triangle, and it will arrive first on the seismogram, which is this wiggle, the data, the actual data that I would use to measure this. But actually, there's a couple of different waves that also will travel. And so we can see that this like pale blue line, the seismic energy first goes up to the surface and bounces off the surface and then travels to the station. And that's this small p, big P arrival. And so basically, by telling the difference between the path that went straight to the station and the path that first went upwards and then went straight to the station, so the difference between the time of arrival of this little p, this P, and then the little p, big P, we can accurately get how deep the earthquake was. And this similarly, we can do the same thing with this second arrival, which does the same thing of bouncing up to the surface and then going to the station. And so that's just a very quick review of seismology, but if that didn't go in, that's completely fine. And so this is just a quick summary of the results that I have from using this method of looking at the seismic waves to work out the earthquake depths. And so you can see in this figure, each of the circles is an earthquake, and the number inside it is the depth of that earthquake. And the colors are just kind of slightly different methodologies of doing the same thing. And so using this, we can see that across the Indian Peninsula, in areas that are far away from the Himalayas, we do have a big variety of the deepest depths of earthquakes. And so possibly we want to work out how that can map into understanding the hazard of future possible earthquakes. So that's all I have for you. The kind of summary and things that I hope that you can take away from this talk is that generally this big picture that strain is accumulating in India due to the collision of India with Eurasia. There's a bunch of different measurements that we can make to show this, including GPS, seismology, and going out into the field. And then the other thing is that earthquake magnitude is related to the size of that fault. And so if we can make measurements of the sizes of these faults, then we can make some assumptions to kind of try and come up with a number of the biggest earthquake that could happen in a region. And so I would just like to say thank you again for inviting me as just an earth scientist to come and talk to you guys. And I'm really keen to make connections and hear your thoughts on all of this. So thank you very much.
Fantastic. Thanks, Andrea and Alex. And I think it's time to have some questions. We already have some exciting questions in the chat. So I'm going to pick one or two and start from there. Right. So I've got Benedict Bayaka. I think just probably a comment. Initial immediate response initiated by the national government unit is to check if all routes leading to the ground zero is passable to ensure the land-based relief distribution can operate as expected. Sometimes air-based relief distribution is not, if that's not possible. And I think probably this may go to Andrea, just probably on your reflection of that question and commentary.
You, Fred, and thank you, Benedict, is a very good point, linking actually to the example that Alice has made. In 2015, if I'm not wrong, there was a large quake in Nepal and affected a lot of rural area, and the only access was possible just via helicopter. Unfortunately, I missed that deployment, but I would have been thrilled to go there. Another good point that Benedict made is about the support and the coordination with the local government. That's absolutely key on any response, because the government, even in my experience, so during my deployment, was a key entity to approach and coordinate the response with. So very good point. Thank you, Benedict.
Thanks for that. Right. Okay, so got another one there, which I think Alice may have. Oh, right. Okay, we've got this one here, which is comes from Alice. So how do you and your team come up with the idea that this is a region where we can find faults in the first place? So let's go into Alice, and again it goes on to say, how do you differentiate between fault and the laminate?
Yeah, this is a really great question. So big picture, we know there's probably going to be faults there because there have been earthquakes there in the past, and because of this big picture of the Himalayas, India crashing into Eurasia, it's likely that there are going to be faults in this region. And then in terms of how do we pick out, part of this is looking at satellite imagery. And so looking at available satellite imagery, you can pick out long straight features in the landscape. But this is where actually going there becomes really important, and how we distinguish between a fault and just some sort of lineament or linear feature is really when looking at the rocks and looking at the offsets in the layers. And so that picture where I showed the gravel cap on top of the rock underneath, showing that actually that gravel was at the same level and has now been uplifted, is how we know it's definitely a fault. So you can make some guesses about what could be features from imagery, but going into the field and looking at the rocks is really important.
Great, thanks for that, Alex. And then we've got another one here. Is understand that India has strong reservations about GPS equipment in the country. Has it given you problems?
Yeah, so that definitely there is lots of hesitation about using GPS. All of the stuff that I've used is done by other people. So I haven't personally gone out and done GPS campaigns. And you'll notice that actually the picture that I showed was a lot of GPS kind of in the regions north of India. So in Tibet and places like that. So yes, they do have hesitation, but luckily I just get to use other people's data sets, and that's not something that I do myself.
Great, thanks for that.
Alfred,
Right, got another one here. Go on,
I can
Mohamed.
jump in. For people who are on the call, please feel free to unmute yourself and turn on your camera and ask your question. That's fine as well.
Now, this is from Ranu, and it's going to go to Alex. So could you elaborate on the mechanisms of interplate faulting, including typical focal depth distribution and the forces responsible for their activations? And it goes on to say that additionally, what are the constraints on the maximum earthquake magnitude that such interplate fault can generate, and what factors control their seismic potential? I think it's just heavy, 3 in 1. So let's go with the first one there. Could you elaborate on the mechanism of the interplate faulting, including typical fault, focal depth distribution, and the forces responsible for the activation?
Yeah, so actually, this is a really great question. And if you have the answer to this, please come and do my postdoc, because that's the question that I'm trying to answer with all of this research. So where it's not super clear right now why those intraplate earthquakes are happening exactly where they are, and what the reasons specific. So yeah, so great question. That's definitely related to the stresses that are being propagated through the Indian Peninsula from this collision zone in the north, but how they kind of specifically accumulate in the regions that do experience these interplate earthquakes, and why some regions don't have them so much is a question that I spend all of my time thinking about. And any insights would be greatly appreciated.
Right, so the extension to that question is additional, what are the constraints on the maximum earthquake magnitude that such an intraplate fault can generate, and what factors control their seismic potential?
Yeah, so this is really related to what I was talking about with the maximum seismogenic depth. So if a fault is kind of square shaped, we want to get one length scale. And so if we can understand what is the deepest depth that could be seismogenic, then we can tell how big an earthquake would be. And in terms of maybe going in a little bit too much detail, but I'll go for it anyway, this is all about the temperature profile and the rheology of rocks. So as you get deeper down inside of the earth, things get hotter, and they go from snapping, brittle deformation, which would be an earthquake, to more kind of plastic deformation. And so but we don't really fully understand, we can't fully map out across all of these regions where this change from a brittle to a ductile regime happens. So actually scientifically, this is interesting for me as well, because it's not just about how big an earthquake could be, it's about what is the structure and rheology of the rocks throughout India. So yeah, those were both really great questions and definitely kind of active areas of research.
Okay. Thanks for that. There's one coming in now, but I will go for my question personally. That will go to Andrea. What lessons from the Philippines experience could we have transferred to other disaster-prone countries?
The lesson learned is First of all, there's a lot to learn from the Philippines, because the Philippines is unfortunately is an epicenter of natural disaster. I was searching up yesterday some data, and the amount of earthquake that hit every day the Philippines is insane. The key element here is what I said in my last slides, is build strong and build better, especially in the rural area. So a level of educations and technical assistance to try not preventive but strengthening the existing structures could be very useful, and also the use of materials, which is adequate material and structurally sound materials.
Great, thanks for that, Andrea. Got another one here, which I think is going to go to Alice. Is from Lindu, also Cambridge University. What do you think will happen to India or to the surrounding areas, the coalition line, in a few million years, particularly with relatively high rate of plate movement?
Yeah, so this is a really interesting question, and actually you can probably, I have no idea where you're based, but you can go and look at mountain ranges that used to be like the Himalayas, but aren't anymore. And so, for example, like across in England, and then it stretches into kind of the US, you have this mountain range that used to be really tall, but is now kind of, small mountains. And that's basically because we have to balance other things that are happening on Earth. We also have erosion happening. So as rainfall comes, it decreases the size of these mountains. And so the Himalayas are only as tall as they are because at the moment the collision is happening more quickly than the erosion can take it down. And so I can't say for certain what will be happening in the future, but I'd imagine that the forces that are causing India to collide into Eurasia will, may change or be different, and then the erosion will take mountain ranges down to a less tall mountain range. I hope that answered your question.
Yeah, thanks for that, Alice. And I think this probably might be the last one here, and that will go to, so it's looking at the post-earthquake typhoons and whether that, there's a link between the number of typhoons after an earthquake and the increase in the number of landslides.
That's correct, Alfred. Say again the question.
Okay. Okay, right. Okay, I think the question is about the linkage between the number of typhoons after an earthquake and how that relates to landslides.
So the effect that happened actually in both scenarios. So landslides happening in the earthquake area up in the north part of Cebu Island, and probably linked also to that large depressions and different type of landsliding in typhoon area. So typhoon, you probably can imagine as large amount of water pouring down and rain in a very short period of time, and that has affected flash flooding and land zones and landslides heavily. So similar effects, but two completely different scenarios.
Yeah, thank you very much. I think I will need to ask this question. It's come back from Ranu and it's going to go to Andrea. It is, what mechanisms exist to enable researchers, students, and professionals interested in participating in post-earthquake field investigations and data collection activities?
Maybe that's a good question for Alice, because I think she may have done a similar pathing. In my scenario, is involvement with the Red Cross, and there are probably a million different ways to enter that international development world. For me, it's been a journey, step by step, starting with first opportunity that I had, joining, an Irish NGOs and do my first experience. But if you really want to be involved at that level, I think you can just walk down to the first Red Cross shop in London and start asking for some volunteering in that regard. That's my thought.
Great. Alice, I don't know whether you want to add a line to that.
No, I have the same question. I thought that was a great answer.
Fantastic. On that note, thanks very much, participant, and I'll hand over to you, Mohamed.
Yeah, brilliant. I think we've come to the end of the session. So thank you to everyone who joined the session and also for the many questions to the speakers. Thank you, Andrea and Alice, for making the time to speak to us today. And thank you to my co-chairs, Alfred and Sarah, and see you in the next lunchtime talk, hopefully. Thank you very much, everyone.
Thank you, Mohamed. Thank you all.
Thank you so much.
Yeah, I stopped the recording.